Hey everybody, this is Chapter 3, Section 5. Title is Working with Sets. Starts on page 194. Going in a completely new direction today. Not anything like what we've been doing so far in this chapter. Stick with me. There's lots of definitions that you need to know and understand. We introduced the idea of a set back in Chapter 2. A set is a collection of things, and those things are called elements. In math, those are usually collections of numbers. Each individual thing in a set is called an element. We'll use those in a minute. We also had the definition of subset in Chapter 2. A subset is a part of the original set that you were working with. We'll do a lot with those today as well. For example, if my set is A, B, and C, then an example of a subset could be A and B. So I took A and B out of the set and made it a subset. I took it out of what I started with. Sets are written in brackets. Okay, that's what those things are called. There are two common ways to write sets. One is called roster form. The other one is called set builder notation. Now, if we talk about roster form, a class roster, for example, is a list of all of the students that are in that class. So roster form is a list of all of the elements in a set. Okay, roster just means list. Set builder notation is kind of strange. We're not even going to really talk about what all it means, just how to do it right now. Set builder notation always starts with this thing, x bar x. Okay, that's the way it's written. And then after that second x comes a description of the set, using words, using symbols. Okay, we'll do lots of examples of those as well. Remember a few other things from Chapter 2. For example, natural numbers. We need to know what natural numbers are. It's going to come up. Natural numbers are the counting numbers, like 1, 2, 3, 4, things like that. Whole numbers, those are all of my counting numbers with 0 added to it. The only thing different between natural numbers and whole numbers is 0. Integers, those are the positive counting numbers, the negatives of the counting numbers, and 0. No fractions, no decimals, or anything like that. Factors, remember, factors are numbers that you multiply together in order to get an answer. For example, the factors of 12 would be 1, 2, 3, 4, 6, and 12. In order to get 12, I can multiply 1 and 12, 2 and 6, 3 and 4, and that makes all of those numbers factors of 12. Here's our first example. N is the set of even natural numbers less than or equal to 12. How do you write that in roster form? Okay? So, first of all, I need numbers that are less than or equal to 12. Things like, well, 12, 11, 10, 9, 8, and it keeps going down. It says I also need natural numbers. Okay? Remember, natural numbers, those are only the positives. No negatives, no 0. And it also says I need even numbers. So, 2, 4, 6, 8, stuff like that. So if I made a list of all of the numbers that made sense with all of these things, less than or equal to 12, natural numbers and even, I would get this list. 2, 4, 6, 8, 10, and 12. All of those are less than or equal to 12. They're natural, and they're even. And I put them in a list. That's what roster form means, put it in a list. How would I write that same thing in set builder notation? Remember, set builder notation always starts with that x bar x, and the rest of it is description. So what do I know about my number? Well, the number has to be even. We had that up at the top. It has to be natural. We had that up at the top. It has to be less than or equal to 12. And I can write that with an inequality symbol. That's pretty much the only reason why they choose to put this lesson right here in the middle of Chapter 3 is because it has an inequality symbol in it. That's the only thing that makes this have to do with anything else that we've been doing. Okay? Writing the solutions to an inequality in set builder notation is a lot easier than you'd think it would be. How do you write the solutions of this problem in set builder notation? First of all, we're going to solve this problem using the same steps that we've done in sections 3 and 4. Okay? It's a two-step problem. N is my variable. There's a positive 9 on it, and it's being multiplied by negative 4. So I have to get rid of one of those first. I'm going to get rid of the 9 by subtracting 9 from both sides. Those cancel because they're inverses. And I get negative 4n is greater than 12. N is my variable. It's being multiplied by negative 4, so I need to do the inverse, which is divide by negative 4. Do that to both sides. Remember, when I divide by a negative number, the inequality has to switch, and I get n is less than negative 3. Now, that's what the answer would have been in sections 3 or 4. Now it wants me to take that answer and write it in set builder notation. The only thing that's different is I put an n bar in front of it, and I put the whole thing in brackets. Okay. So this part just shows up right there. I have to put an n and a bar in front of it, and I surround the whole thing with brackets, and that's my answer. I don't really have to think about anything to get from the inequality to the set builder part. A couple more definitions. The empty set, which is also called the null set, is a set that has no elements in it. It's empty. There's nothing there. The empty set is a subset of every set. There's a lot of sets in that sentence. What that really means is, say I have a pie, for example, and I'm going to take out something from that pie. I can take out nothing, right? If I have something there, I can always take away nothing from it. That's what you're doing with the empty set. You're taking a set and you're taking nothing out of it. We write the empty set either with empty brackets right there, or a 0 with a line through it, like right there. Those mean the same thing. Here's an example that's in your book, but I want to mention it anyway. It says, what are the subsets of the set 3, 4, 5? So I'm starting with 3, 4, 5, and I'm trying to pull things out of it. Well, we just said that the null set works is a subset of everything, so I can take out nothing from 3, 4, and 5. I can take each number out one at a time. So 3 would be a subset, 4 would be a subset, and 5 would be a subset. I pulled them out one at a time. I can take numbers out 2 at a time. I can pull out 3 and 4, 3 and 5, or 4 and 5. I can take them out 2 at a time. Or I can take what I started with and pull out all 3 at once. Okay. So, this example, there's a total of 8 subsets. Okay. Every time you have 3 elements in a set, you're going to end up with 8 subsets. That's just a pattern that you'll eventually see. Now let's do an example that's not in your book. What are the subsets of the set A, B? Well, I can pull out the null set or the empty set again. I can do that every single time. That's the one that people usually forget. I can pull out my letters one at a time. I can pull out A by itself. I can pull out B by itself. Or I can pull them both out, A and B at the same time. Okay. This problem has 4 subsets. Every time there are 2 elements, you're going to get 4 subsets. That is also a pattern you will find out. A few more definitions. The largest set that you're working with in a problem is called the universal set. Another definition, the complement of a set, all of the numbers from the universal set that you started with that weren't taken out by a subset. You can kind of think of it like being leftovers, okay? So your mom or whatever makes a huge dinner, and everybody takes some out of the dishes that you're serving it in, and then you've got stuff that's left over. Well, the complement of set is kind of like leftovers, okay? You took some stuff out, and there's some stuff left behind. The complement is the stuff that's left behind. The way that you write complement of a set is you write the name of the set with an apostrophe after it. For example, A with an apostrophe means the complement of A. We'll see how that looks in a real problem on the next screen. In example 4, it tells me that the universal set is U for universal set equals all of the months of the year. Okay? Set A is all of the months with exactly 31 days, and it asks us to find the complement of set A and to write it in roster form. Well, first we need to figure out what U is. U is the months of the year, so I write out all of the months. Set A are the months with exactly 31 days, so I write out set A, all the months with 31 days. Everything that's in A, I'm going to take out of my universal set U. So January goes away, Marches go away, the Mays go away, the Julys go away, and August, October, and December. So I took away everything that was in U and A at the same time. Whatever's left over is going to be my complement. Okay, remember, complement is A is my letter with an apostrophe, and I had February left over, and April, and June, and September, and November. So the stuff that's left over, that's what goes in my complement set. Practice problems for this section, page 197, 9 to 27 odd.